Welcome to another video from explainingcomputers.com and to the second episode in my series about Raspberry Pi home automation. Specifically in this video, I'm going to be using a Raspberry Pi to control these wireless sockets. So let's go and open up this rather exciting box. So here we have our wireless sockets, which as you can see are from a company called Energenie, and specifically this is the Energenie Pi-Mote control starter kit, which cost me £21.99. And I say it's the Pi-Mote control starter kit because when I first got this and got it out the packaging from Amazon, I went, no, I've been sent the wrong product, because here on the front we can see a remote control socket, but a handheld remote control. And in fact down here it says this box contains a handheld remote control and two sockets. There's no mention of a Raspberry Pi at all, is there? But there is a label on that side, and the label does make it clear that this contains two sockets and a Raspberry Pi controller board. So let's get this thing opened up. Should be nice and straightforward. There we are. That was nice and straightforward. Very simple. And here we are. Oh, there we are. That's the bits we have inside. So let's give you a closer shot of those. And as you can see, what we have here, get it out of its little packet, is the Raspberry Pi controller board. Come out, come out. Doesn't want to come out of its little packet. There we are. There's the Raspberry Pi controller board. And these clearly are our sockets. Let's get them apart, get rid of the thing there. So we've got two sockets like that. Well, they sit there somewhere like that. And then we've got the control board. And I should point out, this is not network hardware. These are not Wi-Fi devices. These are straightforward wireless sockets which don't go onto a computer network. I think they're 433 megahertz, but don't quote me on that. And so these basically just allow us to control things from a Pi, but not over a network. So if I bring in a Raspberry Pi, here's a Raspberry Pi 3 Model B+, and this board will simply go on the top by the GPIO pins up like that, I think, if we just get that in there. And I'd point out this will go on any Pi, so from the first Raspberry Pi Model 1 onwards, you can put it onto any Raspberry Pi you like, which is clearly very good. And on the sockets themselves, we've only got one control, which as you can see is here is a button, nice little button, and that button can be used as a manual on-off, and it's also used to pair the sockets with the control board that's on the Pi. So talking of doing that, I think it's now high time to get this all connected up and go and look at some code. Right, here I am back again, and as you can see I've got the Raspberry Pi all connected up and running in a nice little mount, and next to it I've got one of our wireless Energenie sockets. And the socket is plugged into an extension lead to give it power down there, and then plugged into the unit itself we've got a plug for this angle poised lamp. If I just bring that in there, I need something you can see when it turns on, and indeed if I press the green button on the unit I can turn the light on and off, kind of overexposes the shot, but we can see something is going on there. That's what we want to be able to do, but rather than pressing the button using the Pi. So the first thing I'm going to do is to put this unit into pairing mode. So I'm going to press and hold the green button, and if I do that for about 5 or 6 seconds I think it is, and there we are now. Hopefully you can see there's now a little red LED which is flashing on the top of the unit. So if we now go to the Raspberry Pi desktop, or more specifically I'm running the browser on the Raspberry Pi desktop right now, and I'm here on the Energenie website where I'm showing you all the different things you can buy from Energenie for the Raspberry Pi. And I just wanted to point out there's lots of different things in this range, and it's all based upon the range of products that Energenie have for controlling with hand controllers. And it's also worth pointing out there are different versions of controllers for the Pi. You can get versions like this one at the top here where you've actually got two-way communication, so it can turn something on and know it's been turned on. But the units we're using here are cheaper units, and these units simply send a code to turn something on and they assume it's happened. So let's open up that product, go to the product page. And the reason for that is because down here there's some useful stuff. If I just scroll down, and there we are, you see we've got product instructions and product software. And if we open up the instructions like that, we'll open them up in a new tab, and obviously go across to the tab, Christopher, there we are. And these are quite nice PDF instructions. Let's just zoom them in a bit, and they tell you about the board itself. There's an original Raspberry Pi 1 with a board attached, and they give you various wiring diagrams, GPIO diagrams, and there's also a table here of what they call code pairs. And the way this basically works, there's one GPIO pin which is used to put the board into what's called ASK mode, which is amplitude shift keying. And then there's another GPIO pin which is used to turn on and off the board's modulator, its transmitter. So basically, you turn on the transmitter, you send a code pair to tell some sockets to do something, and then you turn off the transmitter, and you keep doing that to control things. If I just zoom in on this table, which shows us the code pairs, you'll see basically 4 GPIO pins, labelled here D0 to D3, are used to send the signals. And you can control up to 4 sockets. But you don't just have one GPIO pin per socket, they all work together to send a particular code. So as you can see, this code here is for turning all the sockets on, that's for turning them all off, 1111 turn socket 1 on, 0111 turn socket 1 off, etc. So if we just get rid of that, we go back to the, oh no, over here, isn't it? I'm forgetting where I am, dearie me. We want to go back to the product page and we go to the product software. And if we just save the link there, you'll find there's some software. I've already downloaded it, so I won't save it again. We'll go and load that in Python. So if we go to Python here under programming and Python 3 into the idle development environment, and there we are. And if I load in the code I've actually taken from the website, which is this code here, this code is fine, but it was written for Python 2. And a few things have changed in Python between 2 and 3 that make this incompatible. And specifically, if we go down here, you'll see there's some print statements there. Well, there were print statements in Python 2, print is a function in Python 3, which means it needs brackets around the arguments here, which aren't there. And also this code uses a raw input function, which doesn't exist in Python 3, it's just now input. So what I've done, you could probably guess, is to rewrite the code. And so if I load in my altered version, and here it is, and I'd point out that for this video series there is a web page which has got all the code I'm using and everything. You can download code there. So this is the same code, but with things like the print functions actually altered to functions. So what does this code do? Well, basically it's got some very, very nice commenting, which is always great to see, and it imports the GPIO module and the time module. And then it sets up board numbering, it sets up a load of GPIO pins to control the actual code pairs to be sent, and then it also sets up one to control this thing called ASK, and another one to control the modulator. And then initially it turns the modulator off, and it also sets up this ASK thing, and it also turns all the GPIO code pairs to false. There's then various instructions which will print on the screen, so we'll read those later. And then down here we then go into a try finally thing which will loop around forever. Where's the end of it? There it is down there. And it basically operates this while loop while true, so it'll loop forever. And it basically gets you to press a key and then sends different code pairs, so it can turn sockets on and off, etc. So that's the basic code. And so if I run this code, which I'm going to do like that, and run module, and that'll hopefully come up. I'll scroll back to see all the instructions. It basically tells you we're going to set things up. And if we go down here, what we get down the bottom here, it's saying, let's just bring that up a little bit so you can all see it on the screen properly. It says hit return key to send socket 1 an on code. So if we look back to the socket, which has still got its little flashing light hoping to pair up with something, it'll basically pair with the first code it gets sent. So if I actually hit return key, it'll be paired up with that. And of course the light has gone on. That's rather good, isn't it? And so if I now send an off code by pressing the enter key again, it'll turn it off. That's good, isn't it? We'll now send a socket 2 on code. We haven't got a socket 2. Not connected at the moment anyway. We've sent an off code. We'll now send an all on code and an all off code. It's clearly working, isn't it? So our first socket is set up. And once it's been set up, it'll keep its setting unless you go and repair it. So let's go back to on and off, and now it's going to send this socket 2 code. So let's try and set up socket 2. So to do that, what I'm going to do is to take out the light and to take out this socket. You can't have them both connected up while you're doing this stuff. And we'll now connect in the other socket here and put that into there like that and put the light in. There we are, and we'll put this into pairing mode by pressing that down. It's exciting today, isn't it? That's now got its little flashing light. And I'll now press the enter key again, and we'll have a socket 2 on code, on and off. all on should turn it on. Of course, it's socket 2 and off. We're now going to send a socket 1 on code. Doesn't turn it on, turn it off. Socket 2 will turn it on and turn it off. So there we are. We've managed to get this thing working so we can control 2 paired sockets, socket 1 and socket 2. So here I am back again, and I thought I'd do a test controlling both of the sockets using timers. And I've still got one of the sockets connected up to this angle point light, and I've got the other socket across the room, and it's connected to this small movie light. And I'd point out you have to have some reasonable separation between these Energenie wireless sockets. They have to be at least 2 meters apart in individual units. That's what, about 6.5 feet apart. And in case you're wondering, the range of these is about 30 meters between the socket and the Pi. It's only a few inches here. That's about what, about 98-ish feet. Anyway, we go back to the Pi desktop here. You'll see I put my clock up I was using in my last Pi automation video. And many of you asked about that clock, and the clock is actually called the Maxlow's Cairo clock, which you can install on the Pi. Anyway, that's the clock I'm using, and the code is going to be based on the code we were just looking at, the one we got from the Energenie website and a little bit. This, for example, is the block of code here that will turn on a socket 1. So what I've done is to take the code I had in my last Pi automation video, which was basically designed to turn things on and off based upon particular times, and I've used that block of code I've just shown you to turn things on inside this code. So we have a look at this. Basically it loads in GPIO and time and date time. All this stuff here sets up all the board numbering and all the GPIOs and things, and this is exactly what we've had in the previous code we had a few minutes ago. And then down here we've got a try and finally loop. They're getting a bit longer here, and basically it's going to say at 17:33, which is a couple of minutes away, it's going to turn on socket 1. There's the code we just saw in the code we were just looking at from Energenie. That'll turn it on, and then it'll turn on the second socket at 5:34, and it'll turn them both off at 5:35. So that's basically what it's going to do. I should just point out I slightly misled you in the previous section. The way this board works is you set up the code pair and then you turn on the modulator to send the signal, and then you turn the modulator off again after a short period of time. You don't turn on the modulator first. You might not care about that, you might care, but I want to make sure I've got this right. Anyway, that's what it's going to do. So I will now scroll up and down aimlessly and run this code. So we'll run the code, and there we are. It is going to be running. We want to be able to see the clock. Christopher's have the clock over there, and we now need to wait for the first time to come up, so I'll speed forward in time. And there we are, the movie light has turned on. I do find this stuff magical. I know it's not magical, but it just seems slightly magical. There's a bit of Harry Potter going on here. And here we are coming up to the next minute. Is it going to illuminate? Are you going to work? Yes, it's come on. Oh, it's amazing stuff, isn't it? And now here we are coming up to our end time. Will both of the things be turned off? Let's see. Yes, everything has been turned off. And I'm quite impressed with this. I think there's really great opportunities to use these Energenie modules in Pi Home Automation. That's just a Control-C to come out of the code there. I'm sure some of you will say this code could be cleaned up a lot, it could be a bit more concise. I'm sure it could, but it proves a principle. I think we've moved forward with another piece of hardware in our armoury for Raspberry Pi Home Automation. In my first 2 Raspberry Pi Home Automation videos, I focused on different ways to turn mains appliances on and off. And so in the next episode in this series, I'm going to move on to look at the use of motion sensors and light sensors as GPIO triggers. But now that's it for this video. If you've enjoyed what you see there, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.